Hello and welcome to yet another lecture on basic electrical engineering, paper code ESEE 101. Myself, Prathita Roy, Assistant Professor of Dr. Sudhir Chandra Institute of Technology and Sports Complex, Department of Electrical Engineering. Today, my topic is an overview on battery. Lesson objective. After the end of this topic, students will be able to understand the operating principle, types, important characteristics, and capacity of a battery. So, battery. A battery, this is known to us. We have all seen the battery in our daily life. So, a battery is a device that consists of one or multiple electromechanical cells. A battery that is used for supplying DC power to small electric devices like flashlight, torch, toys, phones, and others. Batteries used in industry also in bulk quantities for supplying DC power to various equipments and electric cars. When a battery that supplies power, its positive terminal acts as cathode, while the negative terminal acts as anode. The terminal that marked negative is the source of electron that flow to the external circuit to supply electric energy to the connected equipment. Following connection of external device with the terminal terminals of the battery, the electrolytes that moves as ion and initiating chemical reaction to take place within the battery. As a result, electrons start to flow out of the respective terminal. The flow of electron, that is the formation, or we can say the constitute the flow of current. This is a symbolic representation of a battery that we have known that one terminal of the battery is positive and another terminal of the battery is treated as negative, or the positive terminal that act as a cathode while the negative terminal that act as anode. So as the days goes on, the technology is being modernized and the battery is available in many shapes and sizes. Say, a miniature battery are used as a power source to the watches, mobile phones, cameras, and others. While the large electrochemical batteries, they are generally used in cars, trucks, electric equipments, protection and alarm circuit. And the Another use of the large battery banks are in backup power for telephone exchanges, computer, and network. Now, if I go through the history of technology, and it is known that Benjamin Franklin in 1748, he was first person that to attempt to develop a battery using multiple linden jars. Using multiple linden jars, it was the first attempt to develop a battery and the first successful demonstration of an electromechanic electrochemical battery was made by Alexandro Volta in 1800. Michael Faraday also worked on battery during the period of 1825 to 1834. Although the battery invented by Bohr was an unique device in different scientific experiments, but the output voltage and the current were not stable for those early batteries. So the British chemist John F. Daniel first demonstrated his development in battery technology that supplies almost steady power to the external circuit in 1836. So this was the history that going behind the formation or say the development of battery. So now we will come to the operating principle of the battery. So conventionally, a lead acid battery that is called a conventional battery that we have seen, a lead acid battery that is consist of six number of lead acid cells in series. It is a six number of lead acid cells in connected in series. So each cell has a 2.0 volts at its terminals during open circuit condition, and the battery voltage is the summation of 6 2 volts, that is 6 into 2, or we can say the battery voltage is 12 volts. In commercial form of such cells, each cell is composed of two half cells connected in series by a conductive electrolyte containing anions and cations. One half cell was the negative electrode and electrolyte, while the other half cell includes the positive electrode and electrolyte. We all know that the negatively charged ions, that is anion, migrate to negative ion, and the positively charged ions, that is cations, migrate to positive electrode. And that follows the redox reaction within the cell. Once the external circuit is connected, it will allow a current flow from the positive electron to the external circuit The electrodes are separated by the separation, the separator that allows ions to flow between half cells but prevent the mixing of electrolytes. So during charging of the cell, the electrons are added at the cathode, producing cations. Anions are oxidized at the anode, then reducing electrons there. During the discharging mode of the battery, each half cell has an EMF, that is electromotive force, determined by its ability to drive electric current so the external circuit. If the electrodes have EMF of E1 and E2, the net EMF became the difference between the two EMFs, that is E1 minus E2 for the cell. This E1 minus E2 EMF is the driving from the battery. So, if the external circuit is connected, if the external circuit that is connected across the terminals of the cell, a current that we have already told that allow a current I to flow through the external circuit, and the battery or the cell terminal voltage V became V equal to E minus IR, where E is nothing but that in our discussion that we have seen that E is difference between E1 minus E2, and R is the internal electrical resistance of the cell. So for an ideal cell which has a negligible internal resistance, and hence we can write that E is nearly equal to V. So that is the E minus IR, that is the voltage drop across the internal resistance of the battery, is equal to the terminal voltage of the battery V. This is the general operating principle of battery. So another part of our discussion is the types of batteries. So the we have known that the batteries are classified into primary and secondary forms. So the primary batteries are single use type and disposable batteries. And such type of batteries can be used until exhausted of energy. The electrode materials that are irreversibly charged during the operation of the battery. The chemical reaction are not reversible and they cannot be recharged. Once the supply of the reactants are exhausted, the battery doesn't produce any electric current. Commercial type of primary cells include alkaline batteries and zinc carbon cells. This is the general conception of primary batteries. The primary batteries are the primary batteries that what we have discussed is clear that the primary batteries are single use type and disposable batteries, because The chemical reaction that we have seen in the operating principle of the battery, that the chemical reaction that are not reversible and they cannot be recharged. And once the supply of the reaction are exhausted, the battery doesn't produce any electric current. So this is the general conception of primary batteries. So another part of our discussion is the secondary battery. So this is the general conception, that is the secondary batteries are also known as secondary cells, or the main factor is the rechargeable batteries. Again, the main factor is the rechargeable batteries. Regenerated the original chemical reactants during charging from external power source. This is the main conception of secondary batteries. They are also known as secondary cells, and the main factor is the conception of recharge, that is the rechargeable battery. That means they can regenerate the original chemical reactants during the charging from external power source. This is the main conception of secondary batteries. Hence, that is why they can be used for multiple times. The basic thing is that this type of batteries must be charged before first time of the use. The oldest form of rechargeable battery is the lead acid cell. In recent days, the portable rechargeable batteries are also available, which are suitable for use in mobile phones that we have already seen in our daily life. The mobile phones where the batteries are rechargeable, the computers and other electric gadgets where the battery that is given in our daily life use, that they are rechargeable. The variation of such type of dry rechargeable batteries include nickel cadmium, nickel cadmium, nickel zinc, nickel metal hydride, and lithium ion cells. This portion is generally known to us, that is lithium ion cells, and we have seen in our daily life this type of batteries. So there is a basic conception between two types of batteries. One is called the primary battery and another is called the secondary battery. And the different conception is and the difference in between the conception is the concept of rechargeable. Secondary batteries are generally rechargeable. So moving on to the another part of our discussion, that is called the capacity of a battery. So the capacity of a battery that denotes by the amount of electrical charge, that is the denotes the amount of electric charge it can deliver at rated voltage. So the capacity of a battery denotes the amount of electric charge it can deliver at the rated voltage. The capacity that is measured in ampere hour, that is the measurement of the capacity of a battery, and it is measured in ampere hour. A small, and this is the ampere hour representation, Ah. A small cell has less capacity than a large cell. As in small cell, the electrode material is less. However, the open circuit voltage, they both develop the are same, that the open circuit voltage that they both develop are same. The rated capacity of a battery is usually expressed as the product of its discharge current. It can supply and the discharge time of 20 hours at 20 degrees centigrade ambient and the rated terminal voltage of the cell. So with the help of an example, we can able to understand that a battery rated as 120 ampere hour can deliver 6 ampere for 20 hours period at 20 degrees centigrade with terminal voltage of 2.0 volt. This is the major conception, while the calculation of capacity of a battery, higher the discharge rate, lower the capacity. So the relationship between discharge current, discharge time, and the capacity of a lead acid battery is expressed at that particular function T equal to Q by I to the power n, where Q is the capacity of the battery discharging at a rate of 1 ampere. I is the current drawn from the battery in ampere. T is the amount of time in hour that a battery can sustain, and N is the constant. The value of N is normally 1.3. So a battery may discharge a small fraction of its capacity when stored for a long time without use. This is due to the presence of irreversible side reaction that consume charge, carries without producing current, a battery life that reduces with enough recharging, and the capacity is greatly least. So the specific energy and energy density, one to technical term that is associated with battery. Specific energy, one of the two technical terms that is called the specific energy and the energy density. So the specific energy is expressed the capacity of a battery in weight, and it is expressed in watt hour per kg. So it is also be called as gravimetric energy density. When the energy density is expressed in capacity per liter of volume, it is called the volumetric energy density. Volumetric energy density. So the cold cracking amperes, that is CCA, is a parameter in the battery that indicates the number denoting the amount of ampere the battery is able to provide at minus 18 at 18 degree centigrade, minus 18 degree centigrade. A charger that is required to recharge a secondary cell because of the same deterioration occurs on each charge discharge cycle. So the consumption of the charger is to, we all know, the charge the secondary cell of the battery. Degradation that normally occurs because electrolyte migrates away from the electrode or because active material detached from the electrodes. Fast charging That is, increases component charge and shorten the life of the battery. Also, overcharging of a battery is not, it is not recommended, the overcharging of a battery. Normally, the low capacity NIMH battery, that is 1500 to 2000 milli to triple zero milliampere, can be charged around 100 times, and high capacity NIMH batteries, that is above 2500 mAh, that survive for around 500 charge, and NICD batteries are rated for 100 cycles of charging. So let us take some example in order to understand that what we have learned in now, some numerical problems. The first one is given that a 12-volt battery supplies 16 joule of energy during an interval of its operation. What is the amount of charge that is supplied? So we charge all know that is energy divided by the potential. So energy is given 60, potential is given 12. So 60 by 12 equal to 5 coulomb. So another is the a battery is rated at 120 ampere hour. For how many hours it will continuously supply a current of 10 ampere? So we all know time, that is ampere hour by current. So ampere hour is given 120 divided by 10, that is 12 hour. So another problem is a battery is required to supply 1 ampere continuously for 1 week to a hardware circuit. Determine the rating of the battery. So ampere hour rating of the battery is given by I current into time hour. So it is given current 1 and 1 week, that is 7 days, and each of the day is 24. So it is given that 168 ampere hour. Thank you.